Okay, we're moving on to our lesson 2 in our unit on matrices, and today we're going to focus on this math concept called the determinant, and then we're going to use this number to help us with a new way of solving systems known as Cramer's rule. So let's just get started with some examples. The first set of problems, you're actually going to find the value of the determinant, and I'm going to show you a little formula that will help you to do that. When you're doing a 2 by 2 matrix, first of all, a determinant is only found for what we call a square matrix, so like same rows as columns, like a 2 by 2 or a 3 by 3. These are called square matrices. These are the only types of matrices where a determinant can be found. And you notice that we've got these just straight lines around the numbers. This doesn't mean that this is a matrix, and it obviously doesn't stand for absolute value. If it were a matrix, it would look like this. So when you see just the vertical lines on either side of a set of numbers, it's understood that they want you to determine the value of the determinant. And here's how you do it. So for these numbers, the way they are labeled, we would call this the element A, and this would be B, this would be C, and this would be D. So to find the determinant, you multiply this direction first, A times D. You subtract then the product of the other two, the B times C. And it does matter that you do them in this order because obviously subtraction is not commutative. So always do the AD product first. So in this case that would be 18. And you always subtract. And this time we're going to be subtracting -4. And so the value of the determinant is 22. And we'll show you in just a little bit one of the reasons why we find that it's useful in helping us solve systems. When it comes to 3 by 3 matrices, I'm going to show you a method that I want you to learn by hand. You can also do these very easily with a graphing calculator, but I think it's useful for times when you are not going to be able to use a calculator to know how to do it what we would call the longhand way. So when you're doing a 3 by 3, the process goes like this. I'm going to erase this vertical line because what you end up doing in a 3 by 3 is you need to take the first 2 columns and repeat them. Okay, so just rewrite the first 2 columns, just the first 2. All right, and now, sort of like we did up here, you know how we did this diagonal multiplication, but for a 3 by 3, I think I'll do some colors here. You're going to start here in the top left, and you're going to multiply this diagonal. Okay, so multiply those two numbers together, and that would be 6 plus, now I'll do the next diagonal. 4 times 5 times 1, that's 20, plus, and then do the next diagonal. 2 times 1 times 2 is 4. Okay, and you're still subtracting, but now I'll change colors just to emphasize this. Now you're going to do the diagonal going the other direction. So the top right-hand corner, multiply these together, that's going to be -8 plus, then you do these multiplied together, that should be 30 plus, and then the final diagonal, 2 times -1 times 1 is -2. Okay, so we take these sums, and we got 30 in this group, minus, let's see, that's 22 plus -2, that's 20. And we end up with our determinant value is 10. So a little bit more involved when it's a 3 by 3, but I want you to use this method. We're not allowing graphing calculators in on Algebra 2, so you need to know how to do this. And so that's how you'll come up with the determinant for a 3 by 3. Now, the reason why we need to be good at finding determinants is because this process called Cramer's rule uses determinants. So Cramer's rule works like this. I'm going to find a determinant. The initial determinant that I find will be just using the coefficients from this system. 1, 1, 1, negative 1. All right, and so we learned how to find the determinant for a 2 by 2, so we multiply this way first, that's negative 1, minus, multiply this way, positive 1. So that initial determinant of the coefficient matrix is negative 2. Okay, now we're going to find a determinant called d sub x, and what this will be is we're going to take these constants, 8 and 4, and we're going to literally replace the x coefficients with these constants. So d sub x will be replacing the x's, the y's do not change. And we find this determinant. So this will be negative 8 minus 4, and that's negative 12. Well, that's the determinant called d sub x. To find x, which is our goal, remember when we're solving a system, we're trying to find x and y. To find x, I'll always divide by this initial determinant for the coefficient matrix. So I'll divide negative 12 by negative 2, and that gives me my value for x. X is 6. Now I'm going to do the determinant called d sub y. Well, this time I'll put the x's back and I'll replace the y coefficients. And find the determinant. So negative 4 minus 8. Oops, I just realized I wrote negative 4 there. That's obviously positive 4. Let's fix that. Okay, 1 times 4 is 4, minus 1 times 8. That's negative 4. And again, always divide by this initial determinant that you get using just the coefficients. So negative 4 divided by negative 2 makes positive 2. And you could check yourself using any other method like elimination. If we used elimination, we would add all these together. X plus x is 2x, that equals 12, so x equals 6, that checks out. And then if I let x become 6 and solve for y, I get 2. So just another way, another method for solving systems, but it's utilizing matrices, and now we understand the value of the determinant in helping us solve these systems. All right, let's try this one very quickly. So the initial determinant of the coefficients, just put the coefficients in an array like this, and you multiply this way first. So it's 12 minus negative 30, that's 42. The determinant called d sub x, you're going to replace the x's, keep the y's, and do this determinant. So 24 times 4 is 96, minus, and it's negative 72. That's going to be 168. And always divide to get your value. Some people stop here, but I haven't found x until I actually divide. So 168 divided by 42 is 4, so that's my value for x. And now I'm going to do the determinant called d sub y, so put the x's back and replace the y's. On this determinant, so 36 minus 120 is 84, and once again we're going to divide by that initial determinant 42, and so that equals 2. So my final answer, x is 4, y is 2. Okay, let's do one with, well, let's do this one so we can be on the lookout. If you did this initial determinant, you lay out your coefficients and you multiply this way, that's negative 12 minus negative 12. Okay, well, since you're going to be dividing by this initial determinant and you can't divide by 0, then this is not going to be possible to have a solution. So in this case, and I think your directions even read as use Cramer's rule to solve. If Cramer's rule is not possible, just say not possible. And it will not be possible if this initial determinant of the coefficients is 0. Let's try a 3-variable because these are a little bit more involved, and this will be our last example. So process is the same, it just takes a little bit longer. So I'm going to do the coefficients first. 1, 3, 1, 1, negative 2, 3, negative 1, 1, negative 2. And then remember, for the 3 by 3, you're going to have to repeat the first 2 columns. All right, and so remember, we do this diagonal multiplication. So I'll just go ahead and put rings around these. So we're going to do those diagonals multiplied together, and then we'll work our way back the other way and do these diagonals. All right, so let's just see what we get here. We're going with the blue way first. So 1 times negative 2 times negative 2, that's 4, plus 1 times 1 times 1, that's 1. Negative 1 times 3, that's negative 9. And then we're going to be subtracting, going the other direction. That's negative 6, plus 3, plus 2. Negative 1 times negative 2 times 1. All right, so this is 5 plus negative 4, or plus negative 9, that's negative 4, minus, and then negative 6 plus 3 is negative 3, plus 2 is negative 1. So this initial determinant ends up being negative 3. All right, now you're going to do the d sub x. So this time you're letting the constants replace the x coefficients. And the others are not changing. And once again, you just repeat these first 2 columns. All right, so let's see if we can do these diagonals. So multiplying this way, that would be positive 24 plus 14 plus, this would be 15. And we'll be subtracting, going the other way, this would be 10 plus 18 plus, looks like that's going to be 28. Okay, so we got 38 plus 15, that's 53, and 28 plus 28 is 56, so that's negative 3. And then to get x, that's, remember, this is the determinant d sub x. I won't have x until I actually do the division. So I divide by negative 3, and I get positive 1. Okay, and I'll go ahead and do the d sub y. And once you've seen that, then you'll, it's just a same type of deal to get z. So for d sub y, I'm going to put the x coefficients back like they were in the original, but I'm going to replace the y's with the constants. And the z's are not changing. So once again, repeat the first 2 columns. All right, and now do your diagonal multiplication. So this is going to be positive 10 plus, this is going to be 6 plus, and this is going to be negative 42. And then we'll go the other direction. This is going to be negative 36 plus 14 plus positive 5. All right, so 16 plus negative 42, that's negative 26 minus, and let's see, this is going to be negative 22 plus 5, that's negative 17. So it looks like that's going to be negative 26 plus 17, which is negative 9. And then once again, make sure you go back and divide by the original coefficient determinant. That's negative 3. Negative 9 divided by negative 3 is 3. So that checks out. Okay, so I won't take the time to do the z, but once again, this time you're going to let the constants replace the z coefficients and set up your matrix the same way. You follow the same process, and you should be able to get a d sub z of 6, and then you do 6 divided by negative 3 to get negative 2. So that's that is it. That's what we're going to be doing in this lesson. So I hope that helps prepare you for the assignment. And if you have any questions, let me know.